Thank you. Thank you. Okay, done. Okay, so I was talking about now we will see how the Six Sigma Y and X works. Let me just show you. Okay, so just now we spoke about the definition of the Six Sigma, and it depends on three different things: mean, standard deviation, and specification limit. Okay. We also looked at what is the sigma level will depend on number of defects that you produce, but you'll be surprised at how do I remember these numbers, or what if I don't have exactly 233 defects? I can have more, I can have lesser. So I'm going to tell you that manual calculation also little later in a while. Okay. But for now, let's quickly understand IPO flow here. Okay. Can you just give me 30 seconds? Just you look at the slide, I'll come back. Hi, can you hear me? Okay. Silence
Yes.
means
Yes, loud and clear.
okay, fantastic. So I was talking about Six Sigma. Okay, so when you look at the Six Sigma, what are the, what exactly the Six Sigma flow is? Okay, so there's something called IPO flow. I means input, P means process, O means output. Okay, where you can apply Six Sigma. You look at this example here in the picture, Mick Grinder example. You see your input fruits. Process is a mixing process. Output is a juice. So when you actually look at input, process, output, IPO. So when I say Six Sigma or a process improvement, where I can do, or where can I apply Six Sigma? So I will say you can actually apply Six Sigma wherever there is an IPO flow. Let me repeat. Wherever there's an IPO flow, you can apply Lean Six Sigma, which means even when you go to bank and you say you need to take loan, bank loan, home loan. When you want to take a home loan, that time also you can apply IPO flow. How? There is something called input in home loan processing, right? That can be a document, that can be other information and all these. Then you have a uh, process of checking your documentation, verifying, coming to your house, checking the civil score, and then O output is your loan amount, which is processed. Everywhere we have a IPO flow: input, process, output. So if you have that, you can actually apply Lean Six Sigma. So in your process or in your department also you will have it, right? Or even in marketing, input in the sense when you get a lot of information, content, raw material, um, demands. Process means you do it, and output will be the result. So in IPO flow, when I talk about your output is represented by Y, okay, Y, and your input is represented by X, and process is your F. So we call Y equal to FX thinking. Y equal to FX thinking.
Can
Later
you repeat
on,
once again?
so in Six Sigma, we can actually apply Six Sigma wherever there's an IPO flow: input, process, output. So this IPO flow, when you say output, output is also known as a Y, which is your project, which is your results, and input is known as a X or input, and F is a process. So this is called Y equal to Fx methodology.
A process means FX.
Process is F. F.
Yeah.
X is input.
Your voice is breaking,
Output,
so I'm not able to.
output, input, process. F is a process. Okay, so let's
X
look
is the
at this.
process.
Yeah, X is a,
Can you
no, no.
document? Can you show it in the Word document so that it will be easy because your voice is breaking?
Okay, see here, Arjun. So Y is your output, X is your input, and F is a process here. Y is output, X is input, F is a process. So we
Got it.
say Y equal to F of X.
Got it.
So there are different names for Y and X, and I was saying that going forward we will be using this terminology. Y and X terminology we'll be using more frequently. Let's understand in little detail. When I say Y is your result or output. So for an example, if I want to improve sales, sales is my Y. Sales is the output that I'm looking at. And X will be your, your sales executive knowledge, probably the information they have, probably the process they are following, probably the experience they have. All these things will be inputs. If I say Y is your success, X can be your maybe experience, your qualification, your hard work, or so on. So Y is the result, and X is the cause or reason for that result. So we'll be using these terminology more often now, Y equal to X. So see here, Y is dependent, X is independent. Y is output, which is result, X is input. Y is your effect, which means what is the outcome, X is called cause or reason. Y is symptom, X is a problem. So symptom means we have a fever. X, what are the reason? It's a dengue or some other reason or what? Y is monitor, X is control. So initially in a yellow belt, we learn about Y equal to Fx. What is the reason when you actually talk about the black belt? One second, I'm just stop sharing. I'll just show you one thing here. Okay. So, so when you actually proceed and when we are in hypothesis testing like analyze phase in black belt, that time we'll be using this thing y and x. Can you see here y x y x? So that time it will be again we'll be using this terminology later. So for that, now we are learning ABC kind of for the entire Six Sigma how it will be done. So you see Y is output or project, X is inputs. So this will be utilized later, hypothesis testing and all, during your black belt. Coming back to our yellow belt topic. So here, now you can actually relate your Y and X anywhere. If I have to say quality, quality is my Y, is my result, and X can be anything, can be like people knowledge about the product, can be their other thing, can be their typing, can be their experience, can be their leadership, can be anything else. So this slide is just to explain you what is Y, what is X from yellow belt point of view. Now I have few questions. Let's see who want to answer this first. A Six Sigma quality means how many defects in 1 million opportunity?
3.4.
3.4.
3.4.
3.4.
Superb. Good, good. Okay. Y equal to Fx.
Y is known as,
Y is
no, no,
known as
X is
independent.
independent, Y is dependent. This is false. This is false. Y is dependent, X is independent.
True, true. And again, let me tell you, similarly,
In
you'll
which
have a
case,
exam question also today. So
in
for
which
Y
case,
and X,
no,
Measure.
measuring process, measure process.
Measure.
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 Shift.
Measure
Measure.
phase.
Surface.
wow,
Measure.
excellent. Okay, very nice. All are paying attention. In which phase of design
Validate,
validation?
Improve
checking,
phase.
sorry, improve, yes.
Improve.
Excuse me, improve.
Okay, Motorola achieved the breakthrough success.
1980s, you said 1980s.
86, 86.
86, 1986.
1986.
See,
Okay,
1980s around they had a challenge. When they implemented, it was 1986. This year you should not forget, 86.
got it, got it.
Okay, perfect. Thank you so much. Now we will start basic statistics. So we'll be learning this, and I'll teach you in Excel
Record.
how to do it and manually as well. And then Microsoft. Little bit of voice. Yes. So you need to keep yourself on mute. Who's unmute? All right now. Okay, Srikanth. Done. Sriraj.
I'm also on mute only.
Okay. 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 So are you able to see my laptop screen again? Let's do some small calculation. Hope everybody has joined. So today what we'll be learning is little bit of calculation. Why we need to learn this? Because this will help us to understand what is the Six Sigma meaning. So this is like a kind of ABC of the, Six Sigma. So the basic we need to learn, and after that you don't have, too many statistics or calculation part of it. So I'll go very slow here, and first I'll explain this, and then I will also tell you some calculation which you can actually do that. Okay. Please understand everyone together. So when I say basic statistics, okay, why I have to know basic statistics? Please understand one thing, that whatever you're doing right now, whatever role you're working at, or whatever designation you have, or whichever company, you will always check, you'll always analyze your performance. How do you do the basic analysis or basic calculation? You look at two aspects of any data. One aspect is called centering, and second is called variation. First part is called Centering, also known as centeredness or central tendency. What does that mean? It means all your data points, all your performance is very close, but you're not hitting the target. Okay. Second is called variation, wherein this is the target, and you see that all time you're far, there is a difference between data point. These are two different problems I'm talking. One is called centering, second is called variation. Let me give you example here with the centering, one more number, numerical number example here. Suppose I'm a team leader or a manager, and if I have 4-5 people and my quality target is 90% to achieve, but my people are achieving like 60%, 61%, 62%, 61%, 63%, 62%. So looking at this data, what do you see? You will see that this is your target. This is what your team performance is. All of your team members are very close to each other. All of your team members are very close to each other, but they are far from the actual target. They are not meeting target at all. Your target can be anything. So when you are not meeting that, this is your target, this is what you're achieving all time. When this is the situation, this kind of problem is called centering problem. Centering problem or central tendency. Are you clear with this problem? Basic one.
Yes.
Real
Yes,
life
sir.
example, sir.
Sorry.
Some real life example.
Okay. So when I talk about your class, right? So you will have some targets like you need to, in order to get your certification or your degree, you need to, let's say, in all, let's say if I talk about mathematics or any subject for that matter, if you have to score minimum 80% or minimum 70%, but all your classmates are achieving 50, 51, 52, so all of them are actually very close to each other, right? All of them are very close to each other. They are actually giving similar result, but wherein the passing criteria was very different. It was very higher. So this kind of problem, we can say it is a centering problem in your data.
Got it, sir.
Second problem is called variation. Now in variation, how do we relate it? Let's say your target is to achieve 50%. Okay. You have people who are achieving 0%, 50%, not 50, let's say 100% directly. Then you have again person who are at 0 and then 100%. What is the average here when you look at 0, 100, 0, 100?
Average is 50.
50?
Yeah.
Okay,
200 divided by 4.
okay, okay. So when I look at this 0, 100, 0, 100, when you look at the overall you say average will be 50, right? But challenge here is it's not meeting you're meeting the target, but the problem is there is a too much of difference in data point. 0, 100, 0, 100. This kind of problem is called variation problem. Understood? So first situation was wherein they were very close by each other, but they were not meeting target. In second situation, they are meeting target, but they are very far from each other. That is these kind of two problem you can actually see in any organization, that centering will be a problem or variation will be a problem. Okay.
In real life example, um, for example, let's take a BPO team. Time taken to complete a file or an order. If the target is set for 90 minutes or something like that, but most of the team members are taking it like on an average minimum. I mean, most of the team members are taking it at least 120 minutes, 140 minutes, 130 minutes. That means they are like closer to that, but target is like set target is like very less.
Correct. So they are close to each other, but they are far from the actual target, which is
Target.
called center point.
Variance,
Hmm.
variance is like some person taking completing the target within 30 minutes. Someone is taking 90 minutes. Someone is taking 200 minutes. Another person is taking 10 minutes. I mean, spread across. Is it correct?
Right. Yes. So they have a lot of difference with each other, but overall, when you take average, it is coming almost target is meeting, but difference is there. So that kind of difference is also very dangerous, because when there's a too much of difference, you really suspect that why this difference is happening. Maybe you don't have a control in overall team, or there's something wrong is happening. So when you don't have a control, when they are not following the similar processes, everything is different. That is where you have to improve your process. So like I said, the variation in terms of your health as well is dangerous. Variation, why the accident happened on the road? Because of the variation. One is driving very fast, second is very slow, not following the rules. So variation is much more dangerous than centering. That's why even the Six Sigma target on reducing variation. Now, when we look at the centering and variation, how do we measure how much is the centering problem or how much is the variation problem? What are the ways to measure centering or variation? Let's understand that. So in order to measure centering, I have three different approaches. One is called mean, second is median, and third is mode. In order to measure variation, I can use range, range, and standard deviation. So I'll tell you very basic thing here. So now let's understand how do you calculate centering or variation related problem in your process or in your department or in your role. I'll give you one example here. So let's say I have a data of sales in terms of lakh. So I have 5 team members. Okay, one is giving sales of 4 lakh, another one 2 lakh, then 3, then 3, then 3. So when we have this kind of data, 4, 2, 3, 3, 3. So this is my sales data. Okay. Let's understand with this data point, how do we calculate centering and variation overall? Okay. So I'll tell you how to do manual calculation also, and you can parallelly do it there. And then I'll tell you in Excel how to do that. So first thing, in order to measure centering will be mean. We can use mean or median or mode, anything. What is mean? Mean is arithmetic average of all data points. And anyways, the definition is also written here. Okay? It's arithmetic average of all data points. So that's called mean. So that will actually tell you what is your mean and what is the targeted mean. So for an example, in this case, can you calculate and tell me what will be the mean here? Mean is
3.
often represented by x
3.
bar.
Mean is
3.
3. 15 divided by 5.
So let's do the calculation. Okay, I have one idea. Okay,
We can
first I'll
open
tell
Excel.
you. Yeah, I will do it in Excel also, and here as well.
So the example data is 42333, isn't it?
Correct.
Okay.
The total is 15, okay, and divided by 5 data points. So it is average, right? So 1, 2, 3, 4, 5. So 5. 15 by 5 is, sorry, 3.
5.
So 3 is the answer. So how to do it in Excel also, I'll tell you parallelly.
Is equal to sum of
So suppose I have data here like 3, sorry, 4, 2, 3, 3, 3. First is mean. So mean is average. You can put this formula average, select the data. Okay. In case you want to know how it is, you can also ask me. I will again go slow and explain the formula. Okay. Second comes median. Okay, tell me.
Simple words. If it is a mean, for mean, it is sum of all the values divided by total count.
That's right. Sum of all the value divided by the data point. So that is what your average is. Second comes median. What do you mean by median? So median is middle data point.
so if it is fifth, so third one, that is 3,
Huh?
right?
No, wait 1 second. Middle data point after sorting in ascending or descending order. So middle data point, and this is if odd number. Okay. If it is even number, so you can say average of two middle data points after sorting in ascending or descending order. Let me explain that. So let's say here we had data, we sorted it in order. So 1, 2, 3, 4, 5. So this one become your median. This is the first scenario. What if you have a data like 2, 3, 4, 5, 6, 7. What will be the answer?
That will be
It is
average of 4 and
average
5,
of
that is
4 and 5.
4.5. 4.5.
Okay, that's right. So one thing that you need to remember is, which is very basic, when you are calculating median, you need to sort data. If you don't sort it, don't randomly select the center one because that will be wrong representation. So let's do it here. In Excel, how median will come? Equal to median, select the data, enter 3. So which is correct? And if I have this kind of data, 4.5. Correct, right? Okay.
Virender,
So, huh,
if
tell
in
me.
case if 7 is not there, the 4 will be the median value, isn't it?
Correct. Yes,
Okay.
because that then it will become an odd number. So odd में easy है, whichever center point you take it.
Yes, got it.
Then comes mode. Mode is most repeated data point in any data set. Which is most repeated data point? So if you see this scenario
First
in
example,
exhibition,
3.
okay. So here 4, 2, 3, 3, 3. So here the answer is 3.
3.
Very good. What if
What
I
if we
have,
have all 5 different numbers?
I was coming on that. If you have a data like 2, 3, 2, 3, 4, what will be the answer then?
3 again.
Anyone?
3. Oh no. Average of
2.5.
Okay.
Just guessing it is 2.5.
Mm-hmm. Okay. Anyone else? Let me see the chat. Maybe you guys would be answering there. Okay, Lakshmi says 3. No, no. Okay, that may be the old answer.
this is an old answer, sir.
Okay.
It's something new. So I guess everybody are trying to learn.
Okay, so now since you do not have any data which is getting repeated, highest number of times, and there are 2 is also there, 3 is also there, which is getting repeated 2 times. In this scenario, there is a small calculation. So there is a small, what do you call, equation kind of, a relation between mean, median, mode. So here mode will be equal to, this is a fixed formula, okay? Mode equal to 3 into median minus 2 into mean. So this is a fixed formula. Anytime you can use it. So first you have to calculate median of this value. What is the median here?
2.
So if you
Three.
put this in order, two,
Three.
who said two now?
3 actually.
Somebody. Yeah, that is wrong, no? Because you have to put it in order. Two,
Yes, 2,
two.
2, 3, 3, 4.
See how quickly I confused you guys. So here, median will be 3 minus 2 into mean. Mean will be how much? 2 to
14
4.
divided by 2. 14 divided by 5.
14 by 5 is how much?
2.8. 2.8.
Okay, now you solve
2.4,
it.
I guess. 2.4, yeah.
Answer will be 9 minus 5.6 equal to how much?
3.4.
3.4. So this is the answer. Now that's all. No more. So mean, median, mode. Mean is very much commonly used in all kind of industry. You say, if you say sales of last 1 month daily basis, so they will say what was the mean, what was the average. So you have to tell. So you can do the calculation like this. Then median. So median will again used when you wish to see that okay, maybe average will not make sense, then you can use median. Example, if I'm a part of HR, okay, and if I have to decide a salary, what I will do is I will actually take median for that matter because I cannot take average because there everybody will have a different salary. So in that case, that is the reason all HR people will take median for salary, and you'll be knowing it. They also always call salary median is here. Okay, they never call salary averages here. So in many places, median will be used when your data is very different from each other. So you use median that scenario. But mean, when you see everything is together, you want to just take an average, it is good to have a mean. Example, if I have to say what is the average salary of this batch, it will not be correct to say whatever the salary that you have because few of you will have some salary, few of you will have extremely higher as well. So there will be a lot of variation also. When there's a too much of variation, if I tell someone that this is the average salary, it will not be right justification for a person who is earning lesser or per person who is earning extremely higher. There's a too much of difference. That's why we can take median in that scenario. That is what statistically considered good. But if all are almost equal, then I can say, okay, let's take a mean of it. Like in the similar department, similar division, then we can look at the mean of it. So usually our all tests will revolve around mean and median. Mode is very less used, just like to see which is the most frequent. That is also again for considering some sort of benchmark, like which is the more frequent, common targets kind of thing that you can decide more. So these are three measures of central tendency: mean, median, mode. Mean is arithmetic average of all data point. Median is middle data point after you sort. Like you say, right, in the road we have a median, the central point. So median is a center point after sorting it in ascending or descending order. Third is mode, most repeated data point. Now, the way we calculated mean, median, mode, we also have to look at the variation point of view because that's important for Six Sigma point of view. In variation, how do you look at the variation of any data point? So suppose if you have a data point like this, 42333, like, how do you calculate range there? The first thing. Range is maximum minus minimum. So whatever is the highest value minus whatever is the lowest value, that will be the range. Before that, I need to tell you how to calculate mode in Excel. So let me calculate the mode also here. It's so simple in Excel. Then comes a variation point of view, maximum minus minimum. So what is the maximum and minimum value here, Dilip? I don't know if Dilip can hear us, but maximum is 4.
Yes, sir. Maximum is
You missed
4
your option.
and
4 minus 2. 2 is the answer here.
yes.
So range is maximum minus minimum. How do you calculate range in Excel? Max, open bracket, select data, minus minimum, open bracket, select data, hit enter. Another measure of variation is variance or variance. Please understand this question was asked in GE and many other companies. This was the interview question for 28 lakh. What is the difference between variation and variance?
So
This
before
was
we proceed, in
tell me.
Excel, for range it was max, the data, and after that, what was it?
Max, you selected the data, close the
Mhm.
bracket, then minus, again
Okay, it's
minimum.
minus. Okay, okay. Thank you, sir.
Okay, then sure, we'll come back. Variance. So variance, what is the variance? Average of square distance of all data points from mean. Average of square distance of all data points from mean is variance. Very important. Okay. Let me see if the formula is already there, then I don't have to write it. Okay, good. The formula is there. So this is the variance formula, and this is the standard deviation formula. Okay.
The formula looks so scary.
It's very easy. I'll explain that. Okay. So variance. average of square distance of all data point from mean. Okay, I'll also write it here. So it's like, first you will say sum of, okay, then x bar minus x1 का whole square. So this is the formula, divided by how many data points? N minus, okay. Let me tell you one more thing here. This is the formula for variance when you are calculating sample. Okay. When you are calculating population, this top portion will remain same. X bar, or that X bar is called as sometime mu also, minus x1 का whole square divided by n. So this is for sample, and this is for population. Now, when you expand this formula, anything like this one. So how you expand? It's very simple to expand this. It will be x bar minus x1 का whole square plus x bar minus x2 का whole square, and it continues. N means number of data points. So let's say in our example there are 5 data points. Correct? How many are there? 1, 2, 3, 4, 5 data points. So it will 5 minus 1. Okay, so let me actually come back and do this calculation here itself. It will be very easy for you. Okay, so this, if I have to expand this,
Sir, so variance, the standard way of representing it is S.
variance to represent as S square.
Yeah, so I mean, from the final answer, we just need to take the square root.
Yes, yes. So that will be the standard area.
Okay.
Okay, so let's do in this way. I'm not sure why this is playing like this. Okay, so here if you see the example, we had data 4, 2, 3, 3, and 3, right? And we have x bar. So x bar is how much? 3, right? Above you have already seen 3 is the answer for x bar. Now if I have to
Hey,
calculate,
sorry to interrupt. I think we missed the point. What is x and what is x bar?
okay, okay. So here, when you talk about the mean is arithmetic average of all data points, which is also represented by x bar. So x bar is this. X के ऊपर एक बार लगाना है x bar, like this. You getting it?
Can you repeat, Dhirendra? Can you repeat?
X bar basically means mean. MEAN, mean. Okay.
Yes. So when you say mean, rather than writing mean, you can write x bar. Mean is also called x bar. Showcasing the mean as x bar actually. So x bar is x and you put a line on the top of that. You put a line like this, x bar.
Got
Are you
it.
getting it?
Got it. Got it.
Yeah. Okay. And when you look at the mean here, mean or x bar, value is 3. Answer in our example. If I'm taking this example to showcase how to calculate the variance. So I'm giving the same example here for calculating variance. So let's say our mean was 3 and data was this. How do we calculate variance? So that example we will do it now. Now looking at this formula, it looks quite complicated. It's not that. It is same like what I have written here. You see here, sum of x bar minus x1 ka whole square by n minus 1. Same thing is here. Sum of x bar minus x1 ka square by n minus 1. Okay. Now, when you expand this formula, when you want to remove the sum, it is nothing but it will be x bar minus x1 ka whole square. Okay. Similarly, again, you will have x bar minus x2 ka whole square.
So X1, X2, X3, X4 are basically the data points. N is the
Yes.
number of data points.
Right. So similarly, you will continue till xn. So it actually continue till 5 data point. Okay, so let's say x third will be x bar minus x3 ka whole square.
So, Dhirendra, here it is like x bar minus x1 means x bar is 3, 3 minus x1 is 4. 3 minus 4 whole square, is it?
Yes, dear. 3
Yeah,
minus 4, 3
Yes.
minus 2, 3 minus 3, 3 minus 3, 3 minus 3. Yes.
absolutely. Then you divide by, let me put the line like this.
Fine.
So,
So it
like this, we have to
continues
do it for all the value data points.
n minus 1. I'm doing it. Don't worry. Hold on. You have to be with me. Now here, how much is the x bar? So x bar is common, right? So let's take this example. Let's do the manual calculation. 3 minus, what is the x1 value here?
4.
So here see,
4.
x bar will be same for all. X bar is 3, average.
Yes.
Here,
Yes, mean
let's
will be
take
same.
these 5 data points, okay? 5 data points are there. So x1, x2, x3, x4, x5. Okay, these are the 5 data points. Let me repeat. X1, X2, X3, X4, X5. So now whenever you expand this formula, it will be till Xn, whatever the data point. So there are 5 means it will go up to 5. X1, X2, X3, X4, X5. If there are 3 means it will go up to X3. So that is how you always open the formula. Now you will take this x bar is nothing but average minus the first data point and you take a square of it. Okay, plus open this x bar minus x2 is how much? 2
2.
Then x bar again 3 minus 3, 2.
Same thing again. Same thing 3 times.
Okay.
All divided by 5 minus 1.
5 minus 1 because there are 5 data point minus 1.
Got it?
Because 1, 2, 3, 4, 5. Okay. So 3 minus 4 is minus 1. Minus 1 ka square is 1.
1.
1. Yes.
3 minus
Again
2
1.
is 1.
Again 1.
1 ka square is 1.
1
Rest all is
0
0.
0 0.
3 minus 2
0.
is 0.
0.
Ka square is 0.
0.
0.
Basically 2 by 4.
Divided
2
by
by 4 is
5
0.5.
minus 4. Then equal to 2 by 4,
2 by 4. That's 0.
which is
1 by 2.
0.5.
0
fine.
0.5.
That's all. Done. We are done. So this is how we calculate variance.
Sir,
Dhirendra, I have a question.
Uh-huh.
so do we need to take
Why
the
should
square root
No, but
or
this is square root, right? So we have to take out the square root. This is square, s square.
so variance is
0.5 is s
basically
square, square root.
yes.
Okay,
Oh,
okay, got it, Pradeep. I'll answer 1 second. Huh? Adira, you were also saying something?
yeah, sir. So this is till now we have calculated is s square. That is variance square, right?
Yeah.
So the answer we got 0.5 was for s square.
Yes, sir. This is the answer, or so this is the answer, nothing else. So variance is this only, average of square distance of all data point from mean. Let me repeat.
Okay,
Average
okay, okay.
of square distance. We are taking square distance of all data point, which is like 4, 2, 3, 3, 4. From mean means 3, 3, 3, 3, 3. This is the mean. So we are taking average because 5 minus 1. Average of square distance of all data point from mean is a variance.
Okay,
How
sir.
to do it in Excel? Very simple. var.s, and you will select the data point, enter. Now in the variance there is another thing called variance for population. In population there is only one difference. When you write this formula, right, it will not be n minus 1, it will be caps n. For population it is represented by this. So that means how much will be the value here? Top portion will remain same, it is 2 by 5. So when you calculate the variance for population, you will take it like this, 0.4. What do you mean by sample? What do you mean by population? Okay, that would be
Yeah,
the
exactly.
question.
That was what I was gonna.
Sample is a portion of a population.
Correct,
Dhir-
correct. So let's say there
Srikant,
are 5
sample is a
data
portion of
points.
a population.
So there, let's say 5 data points are there, right? Assume that I have 5 data points. I have only 5. Okay. So I have only 5 people. That means it is a complete population I have, and I will calculate what is the variance. Then it is this. But if I have 10 people, 15 people, or more than 5, and I'm just taking 5 people, means I'm taking a small sample. So when I'm taking a small sample, I can calculate using this, and wherein it is divided by n minus 1. That's the only one difference. So in population, you have to remove that -1. That's all difference. 2 by
So the
4
more
plus
accurate one would be population, right, sir?
It depends on the situation
so
actually.
actually
Depends
what
on data.
happen is most of the time you will be calculating and you'll be checking the sample because it is considered that you cannot check population almost in all the cases. And when somebody asks you to calculate variance, you will be using the sample formula only, not the population, unless it is told that please calculate using population formula. So when you say population, it's a very big thing which people will not be measuring. Okay, so sample is the one answer that you can take out.
Dhiren, I have a doubt.
Please tell me.
Yeah, so if I have to calculate for complete organization, everybody,
Mhm.
then I would go with population, right? But if I'm calculating for each department or something like that, then it would be sample.
That can be one way. And in each department, or let's say in our entire organization, you take few people or few departments, that is again a sample. Out of, let's say now when you consider one department and you wish to consider everybody from that department, so that department become a population,
Population.
right?
Okay.
Uh,
Hmm.
and if you pick some from there, it is a sample then.
Okay. And also, I have some other doubt. It might sound a little silly, but I'll just ask you. So we are calculating all this range, variation, and all that. So whatever we are calculating under variation, right? Is
Mhm.
that we're going to utilize for centering?
No, whichever I'm calculating under variation, this will be only for variation related part. For centering, we have only three options, mean, median, mode.
No, like my doubt is, do we use variation in order to calculate like how deviated we are from our target? Because you said centering is all about achieving the targets, right? And understanding how far we are from the targets.
Okay, okay.
So in
So,
centering, we are able to calculate the median, the mean, all of that. And in
mhm.
variation, we are calculating how far we are away from that. Is that what we are doing?
Oh, no, no. So, good question. In centering, we look at the overall how far we are from the actual and overall target. And in variation, we look at how much our data point is far from each other. So the comparison is happening.
Okay,
Suppose,
okay.
let's say, so in a class, let's say we say everybody should score 90%. So we are just trying to look at whether everybody achieved, how far they're from there. But when we look at the difference in that, one person scored 80%, second scored 60%, and we say, oh, there's a too much of variation in each other. So that is the variation part.
Okay, okay. Understood.
Very good question. Okay, so last thing which is there is standard deviation. That is the reason we have to
Uh,
learn variance.
During the Srikanth here, I have a question.
Tell me, tell
First,
me, tell me.
again, I understood the formula, but I would like to know why variation, checking variance is important.
So in
Sorry.
any data, yeah, in any data we have two problems. One is called centering, and second can be variation related problem. Now, when you are making any product, and if I have to say how much you are making, whether your product are good or not, acceptable or not, so especially in an organization or your client will give you a target that whatever parts you are making should not have too much of variation, right? So there's a tolerance is given, the targets are given. So that time we have to measure. If target is given in terms of variance, we'll have to measure whether all our parts has this much of variance or more variance or lesser. So this target will be given by the customer. Like in this case, it's a 0.5, right? let's say if customer says that I want only 0.3, then we are out of the line. So I'll have to check all my parts whether it is meeting the customer requirement or not, whether there is a too much of variation.
Got it.
And yeah, variation is very important. Like I said, it impact more than the centering, because if you are able to remove the difference in data point, you can automatically achieve the overall goal as well. So third point is standard deviation. So standard deviation is very, very simple square root of variance. So whatever the value you have got, you should just put a square root here. That's all. I'll tell you how.
Be it
See this
variance by
formula you have
population or be
used.
it by variance by sample. It is, for both the case, it is same. For standard deviation, the square root of variance. You mean to say it is square root of variance by sample or square root of variance by population? Both are same.
No, I'll come to that point. So that's different. So what is standard deviation? The way I gave you definition, one-liner definition I created here, I'll create it here as well. So it's average distance of all data point from mean. Average distance of all data point from mean is your standard deviation. How do you calculate standard deviation? Is you put a square root of variance. Okay. Now, in standard deviation, again, there are two things. One is for sample, second is for population. So when you are putting a square root on the sample, then it becomes a sample standard deviation. So let's say you put a square root. When you put a square root of 0.4, that will be the sample standard deviation, like here, equal to SQRT, means square root of the sample is become
0.7.
0.70. And if I want to check for population, again, square root of
0.63.
yes, 0.63. Okay. So this is when you want to put a square root. So just whatever the value was there, if you see this formula also very carefully, I have not done anything. I have just put a square root. Inside the whatever the formula was there, it remains same. And you got the value 0.5 and 0.4, and here 0.5. You just have to put a square root. That's all. That's the answer. And you can directly also calculate standard deviation in Excel. Equal to SQRT, sorry, not SQRT, STDEV, standard deviation dot S means for sample, and you will select the data point. Hit enter. That's the answer you have. And similarly for this, STDEV dot population means P. You select the data, close it, enter. So this is your standard deviation. So if you know the variance, how to calculate it, standard deviation is also similar, just you have to put a square root and the answer is there. So with this, you learned how to calculate centering and variation, because this will help us to see how much we have problem in terms of centering, how much variation we have a data in data point. So I extensively used variation related measure, largely standard deviation. For an example, I do remember when I used to check quality performance or cycle time or AST or turnaround time. So all managers, they used to come up with their report. They used to say, sir, our target is 99% and or 95%. We are at 93%, 96%, whatever. And they used to show everything around the centering that, okay, in this, average is this, average is this. And then when I used to look at the variation in the data using the standard deviation, I used to significantly find the area of improvement. So when we started working on the variation part, we were able to improve the overall centering part as well. So that actually gives you a lot of hidden factory of the success. So you can actually check variation within your team, within your department as well. Who is doing more, who is doing less. So that gives you one prospect, one aspect of your performance. Centering gives you another aspect of your performance. So you have to look at both.
So, can you give an example or a clarification as in why variance of sample and by population?
Why variance of sample? Okay. So that was, see what happened is whenever you look at your performance, you would not be measuring population all the times. For an example, I was telling in our case as well, when we used to do quality check, we were not checking each and every product, right? So what was happening is we were taking some sample and we were telling this is the quality. So in most of the case, even in hospital, right, doctor will not take entire blood out, do the checking
Okay.
and fill it back. They take a small sample and then based on that they make a conclusion. And similarly, when you look at today, how is the update of coronavirus? They are again taking a small sample and based on that making a conclusion. So everywhere it's only
Okay.
sample calculation that happen. Population is very rare and very rare and very difficult also. But if that happens, that's good. So that's a second stage.
Okay, sir, in case of this health related things, okay, but what in case we need to check the performance of the company? Generally, suppose we have our company branches in maybe India, Dubai, and Malaysia. So if I want to compare that, how will sample work?
So if you want to compare your performance, you can compare, but again, for on what basis you want to compare? Question number one. Do you want to compare based on the delivery of the shipment, or you can say anything for that matter? If you say the revenue part, if you say the product delivered, what you want to compare. So even if you say the
Okay.
product delivered on time, yeah, tell me what is the matrix?
Yes, sir. In case all the branches they have equal I mean they have the same departments. Their targets for the month is the same, and overall the work and everything is equal. So we have to analyze on the basis of the profit. So
Mhm.
in that case.
Profit. Okay, so if we have to check based on the profits, like what was the sales and everything happened, or
Overall, sir, maybe now we have five different departments. Maybe the overall, maybe which branch could, you know, I mean, spend less, or overall they could save more, make profit overall. Not just sales, overall.
okay, I get that point. In that scenario, let's say there are multiple branches and you want to look at each branch wise expense, saving, I mean, whatever the money they have earned. you know, investment and so.
Okay.
So that again, you can look at if you are actually uh, looking at all the product. If let's say you are calculating expenditure for all department, everything is same, and then you think that this is the maximum that you have, then that's where it will be a kind of population comparison, right? But
Okay.
if you are taking a few samples, right, and let's say everything is not similar, it's just like a random few expenses happen. I do remember, when I was helping couple of corporates, expenses were definitely not the similar because it varies depending on the kind of even the employee expenses, the maintenance, and it used to vary little bit. So in that case, we used to consider, okay, this is one of the samples. Then it become a different scenario. So it's absolutely your call. There will be hardly small, there will be hardly some difference between sample and population because it's just -1. And this you have to consider based on if you are able to collect every data point, then it is a population. Let's say you have 100 people working, you have a sales target of or sales report of all 100 people, and for each sale, then it is a population. But if you are randomly selecting few or lesser than 100, then it is a sample. That's how it will be.
Okay.
Okay,
Yeah, fine,
so
sir.
just to
Yeah.
yeah, so just to summarize, when you look at centering and variation, these are very, very essential for looking at overall process performance. And you as a manager, you as a leader, please look at all the aspects. And trust me, there will be multiple questions from here itself, whether you are going for interview or anywhere. Now, if you're going for any managerial position interview as well, and if I'm sitting in a panel, I will be also asking that how do you look at the performance? How do you check the overall whether you're meeting the target or not? Do you look at the centering or variation? So you need to have a clear understanding. Okay, I will look at both. Okay, centering if I have a target, if I'm meeting that target or not, or how far I'm from target. Variation means how much difference I have in my data point. So that gives me clarity that how much I have to work or which team has more variation. So all these things. Next topic we have is Six Sigma matrix. Very interesting topic. Okay. So I'll first show this thing in a PPT and then I will actually do the calculation in Excel also. That will be much easier for you. So when you look at the Six Sigma matrix, there are few metrics in the Six Sigma. How do you calculate? Okay. So before that, let me actually give you one example parallelly so it becomes easier. Okay. So you see this picture. I'll just copy and paste that picture here also. So this is, let's say, defect, this black dot, okay? Now there are three parts, one, two, three, one, two, three. So this is situation A, situation, okay? Situation A, situation B, okay? So how many units are there? What do you mean by unit? First of all, let's understand. So, okay, you see this?
Uh, in simple words, unit is like a piece or a product
Good,
or a file.
right? So let's say I have mouse, okay? You see my laptop mouse, okay? So when I bought the laptop, they have given mouse, charger, laptop bag, everything was there. That time, that was 1 unit for me. Okay, the entire set was 1 unit for me. Next time my mouse was not working, I got the lab only mouse. Then mouse became 1 unit for me. Third
Sorry,
time,
repeat.
next time mouse was not working, I bought the new mouse. That became a unit for me. Third time,
Got it.
battery got over. I just got the cell battery, and this became a unit for me. Okay. Now, what does that mean? Unit is any product or service for which customer is ready to pay. Again, I repeat, any product or service for which customer is ready to pay. I was ready to pay first time laptop plus charger plus mouse. Without mouse, I would have said, no, I don't want to buy it, right? Or without charger, I will not buy it. That was 1 unit for me. Next time, if charger doesn't work, only charger become a unit. Or maybe mouse doesn't work, that become a unit. And third time, only battery become a unit for me. So what is unit? Any product or service for which customer is ready to pay. Okay. So it depends. Sometime, let's say if you are working in a marketing area or digital marketing, for you, first time when any client is meeting you, he become 1 unit for you. Okay. And in that particular unit, when you look at this, he actually asks you different things. He can ask you to do advertisement on the Facebook or other social media. He can ask you to do advertisement in maybe the Google, or he can ask you to do changes in any other platform. So these are the different things which he is asking. These are the opportunity for you. First time. Maybe next time, instead of that, then he classify that no, he will only pay. Let's say next time he is coming to you and he says that, you know what, I only want social media, or I want only to focus on the Google. So that become a unit for you. In that again you look at that, okay, what are the parameters? What and all things is looking at? Is he looking for the ROI part, or is he looking for some other branding part or something? So when you look at the change, same customer, earlier he was a unit, then his requirement is a unit, and then slowly his parameter become a unit for you. So in simple terms, when you get a product, or let's say a cell phone is a unit, and all the features that I look at, the screen and whether the keyword, keypad and all these are parameters, which is the next one. Or I would say opportunity. So opportunity is any parameter or specification for which customer is, so one second, any parameter or specification, I would say, which is critical for customer, business, marketplace, and regulatory. That become opportunity for you. So for an example, when you buy a cell phone, you look at all these aspects. When you buy a car, you look at everything from customer point of view. Is it, what are the critical things from business point of view, from marketplace point of view, from government regulatory point of view, that become opportunity for you. So what will be the regulatory requirement from vehicle point of view? All your documentation, tax and everything, What become marketplace opportunity? Your branding, your share price, all other quality aspect. What become a customer opportunity here? Like customer point of view, whether the car is really durable, comfortable, good quality. What become business point of view? Whether this is cost effective, you are able to give a better margin to the company. Then what is defect? So defect is related to opportunity, okay? So any parameter specification which is critical for customer, business, marketplace, and regulatory is not meeting requirement is your defect. This was another recent interview question for 30 lakh rupees. People did ask that what is defect, what is defective. So defect is based on the parameters, So let me tell you, in this cell phone, okay, in this cell phone, if keypad is not working, camera is not working, screen is not there. So there are three defects. Okay. So whatever parameter is not meeting, that is defect. Next comes defective. So here, any unit which is not meeting customer, business, marketplace, and regulatory requirements. So now, what did you understand with these four things? Your unit, if it is not meeting, is a defective. So when there is any parameter which is not meeting, and when you look at the parts wise, it is a defective. Defects will be opportunity wise. For an example, if I say in cell phone, I was trying to tell you that, the screen is not good, keypad is not good, camera is not good. These are defects. But how many defective? Only one, because one laptop, one mobile is not good. What is the unit? Unit is one. What is the defective? Defective maximum can be one. But how many defects? Multiple. How many opportunity? Number of requirement that you're looking at. These are the basic things which we need to know in any project or anywhere as well, because you need to tell your stakeholder that what do you mean by unit, what do you mean by opportunity and defect and defective also. In this scenario, let's take this example here. So let's say there are three products, 1, 2, 3, and here also 3. Let me take example of the top one. How many units you see here? 3. And how many parameters or opportunity you see here?
6.
6, 6, 6. Total 18. Second thing here is how many defects are there? 1, 2.
2.
How many defective?
2.
2. But in scenario of this, how many defects are there? B. 1, 2, 3, 4, 5, 6, 7.
7.
How many
Defective
defectives?
2.
Okay. So these things are clear till here. These are the basic. Now we will actually use Six Sigma matrix. So the first one is called DPU. DPU stand for defect per unit. Defect per unit. So when you say defect per unit, how do you calculate it? You just put a formula here only, I think, equal to total units when you look at here 3 2 by 3. Okay, so here it will be total defects divided by total units. So how many total defects are there? And total unit 3. How about B example? This. Second matrix is ppm, that stands for parts per million. Santosh, you would be using this in your organization, right? Do you have the ppm calculation there?
Sorry, come again.
Do you measure ppm there in your company? Because in all
Yes, sir.
manufacturing everywhere they use it. Yes.
Yeah.
So ppm is another measurement. Total defect divided by total unit into 1 million. 1, 2, 3, 4, 5, 6. So it will be total defects, or you can say DPU into 1 million is also same. So total defects divided by total unit into 1 million. 1, 2, 3, 4, 5, 6.
What does this ppm indicates?
So this is one of the measurement which tells how is your quality level. Parts per million, that means how many parts were rejected out of million, kind of. So it's like that.
Mhm.
Then we have now only two more are there. Another one is DPO, stand for defect per opportunity, which is equal to total defects divided by total opportunity. So total defects are 2, opportunities 18. Then the last one is DPMO. This you would have initially heard today. Defects per million opportunity.
3.4 defects per million opportunity.
That is for Six Sigma level. Correct.
Yes.
So how do we calculate this? Total defects divided by total opportunity into 1 million. 1, 2, 3, 4, 5, 6. Sorry. So here, total defects divided by total opportunity into 1 million. 1, 2, 3, 4, 5, 6. So when you said a process is Six Sigma process or anything, right? So in Six Sigma process, how many opportunity I said out of 10 lakh, right?
Yeah.
Yes.
Six
Yes.
Sigma process, I mentioned one thing that total opportunity will be 1 lakh, sorry, 10 lakh. 1, 2,
Lakh.
3, 4, 5, 6. And how many defects? 3.4. So if I have 3.4, it's coming in the same way. Okay, I'll show you this calculation in different way. So that same thing, DPMO, right? That's the same thing I'm calculating again. Okay, so let me calculate the last thing, which is called sigma level. Sigma level is, we'll put a formula like equal to norms INV. This is the last calculation. After that, we are done. Norms INV equal to 1 minus defect divided by opportunity plus 1.5. So equal to norms INV. This formula I discovered, wherein you don't have to remember those numbers that in Six Sigma 3.4, in Five Sigma 232 kind of. You can use this formula and you can calculate. So 1 minus total defects divided by opportunity plus 1.5. So it is your sigma is 2.7 now. And for provider B, it's supplier B 1.7. And here it is Six Sigma. So how did you get the Six Sigma? Now 3.4 defects are there out of 1 million means Six Sigma process. Can you see this? This is what we learned initially today. You saw this, right? Six Sigma 3.4 defects, Five Sigma 233 defects. So instead of 3.2, let me put this. It's showing 5 sigma. Can you see?
Yeah.
If I put here 308, 537, 2 sigma, can you see that? So it will actually, if you remember this formula, it will help you to calculate what is your sigma level right now also. So I'll share this Excel sheet also with you so that you can actually do the practice and see what is the sigma level for any processes. Try calculating for a few processes also.
Okay, so the calculations are done.
Yeah.
Sir, actually, I couldn't just see the screen in between. I just got lost after unit. But I could get from where defects and all. But then what is defective?
Defective means how many rejection are there. Defective is largely with the product. So how many product were rejected? That's called defective.
So in this example, how did we get the, I mean, two as the,
Very good. So here, out of three, let's say here also you see one defect, here also one defect, right? So
yeah.
defective is unit wise. So this unit is also rejected, this unit is also rejected. But this is
Okay.
very good. There is no problem itself. So out of three, these two are defective. And here also out of three, these two are defective.
Okay.
Okay, quiz time and my time. I can ask now. And hope you're not referring the notes, you're only seeing the screen. So first question is for Naveen. Below is the delivery time for 5 different items delivered on the particular day. Calculate mean of delivery time. Naveen, oh you did.
Yes.
No answer. You're saying
It's 4 hours.
वाह, आपको मिलते हैं 1 करोड़ रुपए. Okay. So what is the mode for above sample? Deepika, what will be the mode 4 2 4 6 2 4 4? Mode will be how much?
Here it's 2.
It will be 4.
4.
Because 4 is getting repeated, na? 4 4 4.
Okay.
Mode is most repeated data point. Okay. What will be the
Yeah.
range? Range is
4.
maximum minus minimum.
6 minus 4.
Maximum 6 minus
4.
2.
4.
So here it's 2.
4.
6 minus 4.
4.
6 minus 2. Maximum is 6 and minimum is 2. So 6 minus 2 is equal to
Okay.
4.
1 second. Huh? This answer is wrong here. 4,
Yeah, there is.
no, 4, 6. No, correct, na? 6 are minus 2 is 4. Correct.
Answer is 4.
Ha, correct, correct. Okay.
Are you testing us?
How about
Are you testing us?
okay? Question number 4. How do you calculate DPU? See here, we said if specification limit is less than or equal to 4 hours. So if you calculate in the previous example, if your specification limit is 4 hours, see here, 1 met, not met, met.
Can you show the question once again? Dhirendra, can
I
you
think
show the
we lost
question once
Dhiren.
again?
I
Hello?
think Dhiren, we lost Dhiren. Maybe he has to come
Okay,
back.
okay. Let's check. Let's check.
Yeah.
Let's check. Can someone tell me what is the question?
DPU. He asked for DPU. Defects per unit. Do you have the question? Hello, can you all hear me?
Yes, we are able to hear you.
Okay. I thought I lost everyone.
I think we should stay like this and then Dhiren will join again.
Okay, maybe he's trying. Let's see. Hold on. Yeah, he has texted on WhatsApp too.
I think the answer is like 0.2.
I don't have the question with me, so no idea.
The question is for the above process, the customer specification limit is less than or equal to 4 hours. Please calculate the defects per unit. So the above example is uh, 4 hours, 6 hours, 2 hours, 4 hours, and 4 hours.
4 hours, 6 hours, 2 hours, and
4, 6, 2, 4, 4. Because
okay.
customer specification is like 4 hours is their target. They have the specified SCSL, means specification limit.
Okay.
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 So items delivered are first item delivered in 4 hours time, second item delivered in 6 hours, third item
Okay.
delivered in 2 hours, fourth
Okay.
item delivered in 4 hours, fifth item delivered in 4 hours. So
Okay.
out of all these 5, only one item, all 4
Was
items are
about
like
the
correct. All the 4 items are delivered met the customer specific limit. Only one item
okay.
6 hours.
Right.
So defect is, one got defected. Okay.
One is defected, right? Okay.
Are we audible to others?
Yeah. And
No, are we both of us audible to others, or only 2 of us are there?
No,
Yes, we are
we
audible
can
to
we
the
can hear
entire
you.
audience.
We're able to listen.
okay. Okay, all are on the same page, yeah?
Sorry.
So
Okay.
we're just listening to the speakers.
Okay, thank you. Yeah, Shrikant, you can continue. So the defect is 1.
Yes. So,
The defect is
can
1
someone
out of how many? The
1
defect is
out of
1
5.
out of total 5 opportunities. So 1 divided by 5 is 0.2.
0.2.
Okay, great.
Okay.
You all were connected, right?
Yeah.
Okay. Actually, what happened? Can you hear me?
Yes,
Yes,
sir.
now. Again,
Yes, sir.
Okay. So it happened when power goes and generators start. In between, Wi-Fi will switch off and switch on automatically, and then this
No problem.
happen at connecting issues.
uh,
Okay.
1 minute there seems to be a latency. Okay. There seems to be a latency.
Can you hear me now? All?
Yes,
Now it's
sir.
clear.
Perfect.
Now it's clear.
Okay. Come back. Thank you. Okay. So we
So
were
we
here
found out that
somewhere.
the answer is 0.2.
Wow, superb.
So we all together found 0.2.
Very nice, because these are your exam question today, all these calculations. 60 to 80% question will be from these two topics.
Dhirender, we found that the answer is 0.2, but we wanted to know whether the answer is correct. I mean, our method of calculation is
Yeah.
correct or not. Could you please
Very
confirm?
much, very much.
Can I explain, Dhiren, guys, or anyone else will explain?
See here,
Anything, you or
so when
Because
you
I
see
want
the,
everyone to
out of 5,
okay,
correct. So
sir.
when you see,
So can I?
Yeah,
okay,
sure. Please proceed.
Okay, so the data points we had were 4 hours, 6 hours, 2 hours, 4 hours, and 4 hours. Right?
yeah,
Right.
Okay, so in total we have is 5 data points.
right,
And our upper limit was 4 hours.
right,
Out of these 5 data points, only in one it has exceeded 4 hours, that is 6.
correct,
So the defect we have is just one defect out of 5.
correct,
which was calculated 1 by 5 is equal to 0.2. This is how.
Done. Very good. Next question. Difference between variance and variation.
Thank you, Shrikant.
Who will answer this?
Yeah,
Welcome.
yeah.
Actually, we should
Sure.
thank Dhirendra.
Sorry, who want to try that? Difference between variance and variation. Okay, I see
Variation is
people
a
are.
problem.
Uh-huh.
Variation is a problem found or diagnosed or identified. Variance is a step or a formula to find out the variance. Am I correct? No.
Okay. Okay.
Am I
Nice.
audible?
Yeah, very much. All times, sir. Don't worry. So
Okay,
that's
I
kind of correct.
said the
So variance. Hmm. Yeah. So variance is the method of checking variation, and variation is a characteristic of a data which shows the difference in data point.
Okay,
Okay.
we should call it as a method. I thought I called it as a formula. Okay.
Sir, so once again, can you repeat it slowly? Variation and variance. There is.
Okay. Variance is the method checking variation, right? And variation,
Okay.
the characteristic which represent spread of data or difference between data points. See, why I thought of putting this topic here, because most of us they will mix these words, right? We'll say what is the variance? So variance is a different method actually. So they will mix, they will use variance as a variation, and that's why it confuses.
Okay, sir.
Another
Done with
interesting
this.
topic for I didn't hear that.
No, I just asked if we are done with the test.
Yeah, yeah, those calculations are done now. Okay,
Okay.
so now we have
Very mild.
background noise.
Who is playing PUBG?
Okay, now it is silent. Okay, so here when you say lean management, we understood Six Sigma in the morning, and now we'll also look at lean very quickly. Okay, and we have a dedicated 2 days training only for the lean management. So what is lean? Where it came from? We understand the way Six Sigma is there. Six Sigma is a US based approach. Lean is a Japanese approach. And lean largely focus on reducing waste. And
Sorry, come
Toyota
again.
actually so Six Sigma focuses on reducing variation, but lean focuses on reducing waste. So lean is a kind of approach or kind of strategy which will help you to maximize value to customer. Lean is a strategy of maximizing value to customer by reducing waste. So this is a Japanese approach which actually help you to reduce waste, which help you to focus on saving your time, reducing your effort, reducing your money, saving your money. So how do you achieve anything faster? You'll be learning in the lean management. So whatever the waste activities are there, you'll be able to remove it. But which are those waste or non-value added activities? That is something we need to learn now. So in lean management, it was actually discovered around 1937 and precisely 1940 they actually formed. So there was a person from Toyota. He actually visited Japan. Okay, he visited US. Okay, so this gentleman name was Taichi Ohano. He also met Henry Ford as well. When Henry Ford, they applied these concepts in Ford when they were actually looking at how to make more and more product, how to make more and more cars. So when they were actually doing it, that's where Taichi Ohano, he visited US supermarket. He also looked at how this Formula One car racing, how many of you know about the Formula One car racing, how it works? So he actually looked at that as well. He met Henry Ford and he actually developed something called Toyota Production System. So Toyota, which we call now, earlier it was known as Toyota Production, Toyota. So they had their own business excellence system. That was Toyota Production System. So how do they do changes and improvement in their company? So they actually made a complete principle, or you can say all the tools and techniques that actually helped them to improve, which was later on so popular across the world, people started using it. And that is called lean management. So lean management is nothing but what you see the Toyota vehicle, all of you know Toyota now, because Fortuner, Etios, all these vehicles are from Toyota, right? So whatever they followed in their company, the way Motorola followed, Six Sigma, similarly Toyota followed this lean approach. So whatever the practices they followed, whatever tools they developed, those are used now as lean management. Why it's so popular, why it's so famous? Because it has significantly shown result everywhere. Even, if you talk about any kind of manufacturing and service today, they actually use lean management extensively. I'll talk about how it works, what are the different principles also. So for today, Yellow Belt point of view, we will learn only few things here. First, there are 3 M's in the lean management: Muda, Mura, Muri. Any word which you hear today from me, apart from English, will be Japanese word. Or one word is German word, which I'll tell you later. Otherwise, all these are Japanese word, and more than me, Abhishek can tell because he knows Japanese completely. What do you say, Abhishek? Okay, so here when I say Muda, Mura, Muri, so Muda is a waste. When you say waste, if you see this gentleman when he is filling it and this water is coming out, so it's called waste activities. Second is called Mura. Mura, if you look at, is called unevenness or variation. You see one bucket is too big, second is very small. When this kind of variation is there, that's called Mura. Third is called Muri. So when you say Muri, Muri is overburden. So when you look at this gentleman, has excessive weight here. So this is called Muri. These 3 M's we'll be learning now. Muda extensively we'll be learning. So Mura and Muri means whenever in your workload or in office, when you have more, too much of work, more than your capacity, that's called Muri, which is not good for you, because when you have more work than your capacity, you'll start producing defect. Similarly, when you have all of a sudden you get more work and sometimes less, it is a waste of your energy as well, because sometimes you'll be idle, you'll not be giving any ROI to the company. But when all of a sudden it comes, that also create a problem because you cannot generate the good quality. What is Muda and waste? Let's understand that. So there are 8 types of muda that we always see. These are very, very important points, and these are the life-changing points. These mudas you can actually remember with the short form called Timwoods. Timwoods. Can you see here in the sequence? If you are able to understand these things, you can actually change your complete